Hello, this is Bill. We'll be covering the CompTIA Network Plus certification for exam N10007. I'm using as a guide for these lectures, Managing and Troubleshooting Networks by Mike Myers. It's the 5th edition of his book. So there are two network models we're concerned with the Network Plus certification. The first one's the OSI 7-layer model, and the second one is the TCP/IP, or some people call it the DoD model. This course will be centered largely around the OSI model, but we'll discuss the DoD model just for some reference, and there is a possibility to get a couple questions on the exam, or probably one question on the exam. We don't spend a lot of time on that, just a few minutes. So there are 7 layers of the OSI model. The layers are from layer 1 through layer 7. Physical is 1. Layer 2 is data link. Layer 3 is network. 4 is transport. 5 is session. 6 is presentation. And 7 is application. Memorize this model. If you're going to stay in networking, you're going to see this throughout your career. And when we talk about this in the industry, typically we don't talk about the network layer, or the transport layer. We refer to them by numbers. So people will talk about that's a layer 1 or layer 3 type protocol. But you will see this quite often in discussions. There are 3 acronyms or 3 mnemonic devices that you can use to memorize this until you get used to it. Starting at layer 7 and working way down to layer 1, the first mnemonic device is all people seem to need data processing. So all is application, people is presentation, seam is session, all the way down to processing, which is physical. Working way up the stack from layer 1 to layer 7, we have please do not trust salespeople's advice. Again, please is physical, do is data link, all the way to advice for application. And the last mnemonic, again working from layer 1 to layer 7, is please do not throw sausage pizza away. When we talk about the OSI model, or the Open System Interconnect model, 7-layer model that we have here, that we've identified, we talk about it in terms of the way data flows and what process takes place at each layer. This slide and the next slide will discuss about the process of that flow. After we discuss that process of flow, we will start talking about the process that takes place at each layer. So let's say you want to send an email. You open up your email client, which is going to be Outlook or Thunderbird, any number of email clients. And it could be a web browser. In this example is just an email. In your application, you type your email. The email application is not actually at layer 7. It's above layer 7. It's actually operating in the operating system of your PC or on your phone. It's above the application layer. You click the send button to send the email. The email client now needs to talk to the network. So it needs to talk to the application layer. It does this using an API. An API is an application program interface. Now, one thing is, I'm going to stop right here for just a second. We use a lot of acronyms in networking, and you should get used to knowing what those acronyms are. For example, API is Application Program Interface. Know that. OSI is Open System Interconnection. Know what that means. And know what these acronyms mean. When you take an exam, I don't care if it's a CompTIA exam, a Cisco exam, Palo Alto exam, any exam you take in networking, we tend to use these, you'll see these acronyms within the exams. It's not there to trick you. These are terms that are being used daily in our industry. You have to know what they mean. So they're not going to spell out things. So the testing organization is not going to spell out words for you. They're going to use terms like API or OSI. Know what they mean. You will have to know what they mean in the correct context on an exam. So let's go back to our email. So our email client uses an API, application program interface, to speak to the application layer. That puts the email message now in the network. That email message is passed down to the presentation layer, where we may add encryption or some other processing of text to data. From there we go to the session layer, where we open a session, transport layer, network layer, data link layer, down to the physical layer, where we actually put this message on the cable and send it to the next workstation. And that's how this model works on a single device. When the device at the far end receives the email, it does this in reverse. It receives the email on the physical layer as voltage, ones and zeros. It passes it up to the data link layer, network all the way up to the application layer, which passes it to the new email client. And again, we discussed this a couple slides back, but each layer in a computer speaks, or a network device speaks to the same layer on a corresponding network device. So let's talk about each layer individually. Let's start with the physical layer, layer 1. Physical layer is where we have our media transport. This is our cabling, Wi-Fi, cellular signals. It could be category 5 or 6 cable. It might be Wi-Fi connection. It could be fiber optic cable. So what happens at this layer? We're largely talking communication signals, voltages, frequencies, light levels, radio signals, ones and zeros. What devices operate at this layer? The repeater and a hub. Now, a repeater is not an amplifier. The repeater itself is a device that takes a signal and cleans up any noise on that may be on that signal, and just transmits a clean signal down the line. An amplifier will take a signal and amplify both the noise on the signal and the actual data. So remember, a repeater takes a signal, strips out all the noise, and retransmits just the signal at full strength. A hub is considered a multi-port repeater. Both of these devices here put here more for historical purposes. You will not be able to buy a hub. Maybe on eBay you can find one, but you will not be able to buy a hub from any reputable dealer anywhere. Hubs just don't exist anymore. They haven't been around for probably a decade. Where you could actually buy a hub. They probably haven't been manufactured in probably a couple decades. Repeaters you will still find here and there. They're rare, but you will find a repeater here and there. But a hub is they're just not made anymore. So layer 2. Now layer 2 is first thing unique about layer 2. It's broken into 2 sublayers, and it's the only layer in our OSI model that has 2 sublayers. The layers of the logical link control and the MAC layer, or the media access control layer. So we have LLC and MAC. The devices that operate at this layer are network bridges and switches. Again, bridges like hubs aren't sold and manufactured anymore. We now currently buy switches. In reality, a switch is a multi-port bridge. A couple other topics you're going to hear layer 2. The first are addresses. This is where we have our first address in networking. And that address is called the Media Access Control address, or MAC address. Layer 2 is where we construct our frames. So at layer 2, we have now our first address, the MAC. We now have our first construct in a frame. We also have error checking at layer 2. Logical link control, and the logical link controls how the data link layer communicates to upper layers of the OSI model. We also have 3 concepts here: broadcast, unicast, and multicast. A broadcast is a one-to-all type communication. So think of a professor in a class, sits up there, talks to a class of, we'll say, 100 students, doesn't take questions, just simply sits there and broadcasts, and all the students are sitting there listening attentively and taking notes and trying to absorb what the instructor is saying. Unicast is a one-to-one communication. It's you talking to your best friend. And multicast is kind of like a broadcast radio station or broadcast television station. The television station is sending out the signal constantly. Your television set only tunes in to the broadcast it wants to hear. That's called a multicast. So a signal goes out to everyone, but the only ones that receive it are the ones tuned to that broadcast. So we call that a multicast. Before we go on and talk about MAC addresses, you have to understand hexadecimal just to this layer here, just to this level. There's not a whole lot you have to understand about hex. But hex is a numbering system that goes from 0 and it's base 16, so 0 through F. The normal numbering system we talk about in school is base 10, and that goes from 0 through 9. So we want to go through 16, so we 0 through F. And the way this works is the decimal 0 corresponds to the hex 0. The decimal 1 is the number 1, 2 is 2, 3 is 3, all the way up to 10, or to 9. At 10, the decimal value of 10 is equal to A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. But it is important, at least we have 0 through F as our hex numbers. And that's the reason that's important is our MAC addresses are displayed in hexadecimal format. So data link layers addresses are called media access control addresses, or MAC addresses for short. Again, remember the term MAC is media access control. On an exam, you may see the term MAC, and that's not just CompTIA. Cisco does it, CompTIA does it, ISC squared, Security Congress does it. So it's very common to see these terms. It's not trying to trick anyone. These are the terms we use in the industry. So they expect you to know them on the exams. You also might see a MAC referred to as a burned-in address, or BIA, EUI-48, or physical address. A MAC address is 48 bits long. It's divided into 2 sections of 24 bits each. The first 20 bits are called the organizational unit identifier. This portion of the address is actually signed by the IEEE, so the Institute of Electrical and Electronic Engineers. Again, another organization you'll have to become familiar with, just because you'll see it in print. So what happens is, if you decide you want to build a network card, you approach the IEEE and say, hey, I want to build a network card. They will assign you an ID, a 24-bit ID. And every network card you build has to have that 24 bits in it. It has the first 24 bits. The second 24 bits can be assigned by you or the company who builds the NIC. And that second 24 bits, a lot of times we'll call that the device ID. So we have the OUI and the device ID. In theory, no two NICs can have the same MAC address. So MAC addresses are displayed in hex format, and again, we have them in hex, which is from 0 through F. Remember, the first 24 bits are the OUI, the second 24 bits are the device ID. So in this case, our MAC address of 0001 1A4653AB is split into two devices, or two sections, where the OUI is 00011A and the device ID is 4653AB. If you want to see the MAC address for your Windows device, you open a command prompt, and let's do that real quick. So you open a command prompt and you type in the command ipconfig / all, and our MAC address is going to be this. Microsoft calls it a physical address, right there. Our Bluetooth device has a MAC address of this. And we have another device up here, our Fortinet adapter, which happens to be one of my VPN pieces of software, has a MAC address of this. For a Mac, you would type in ifconfig, and for Linux is IP-A. Now keep in mind, a MAC address can't be routed across the network or an internet. Its communication is limited to its own local network segment. And the MAC sublayer actually provides two other functions that we need to discuss. The first is it takes our message, our email, in the case of the last example, and it translates that from semi-human readable and machine readable into ones and zeros, and transmits these ones and zeros as either pulses of electricity for copper cable or light for fiber optic on the network. The NIC also organizes data into a frame. For the Network Plus exam, you only have to be familiar with the Ethernet frame. The Ethernet frame varies in size. Its smallest size is 64 bytes. Its largest size is 1,518 bytes. And it'll, of course, vary depending on the amount of data being transmitted. The structure for Ethernet frame is this. It's got 5 fields. The first one is our destination MAC address. This is where we're sending this frame. The source address is the MAC address of the sending network device. The type, sometimes called ether type, tells us what kind of data is actually in the frame. So the portion next to it is our data. And that data is going to vary. That's just going to be our email address or URL. It's going to be something that we're going to be in the system. It's data we're transmitting. And the last part's our frame check sequence. The frame check sequence is the part we use for error checking, error control. It's a mathematical algorithm called a cyclical redundancy check. And the way this works is the sending device takes our information, calculates this cyclic redundancy check, puts it in that 4-byte field, and transmits it to the receiving computer or receiving network device. The receiving network device kind of strips off that frame check sequence, does the same mathematical algorithm, and then compares what it comes up with what was transmitted. If they're identical, no changes occurred during transmission. In other words, no errors in the frame, and the frame is passed off to the next layer. If there's a difference between the calculated CRC and the transmitted CRC, the frame is simply dropped. Now the logical link layer is the second sublayer of our data link layer. The LLC actually acts as the interface between the MAC layer and layer 3 of the OSI model. So this is where we're going from the MAC all the way to network. The LLC does that translation. Some other properties of layer 2. There are 3 types of transmissions that occur: a broadcast, This is when one broadcast transmits and all of the devices on the segment receive that transmission. Not only receive it, but they actually look at it and process it. A unicast is where one network device transmits only to another network device, so it's a one-to-one transmission. In multicast, we have one device that transmits to many devices that are listening. Protocols that operate at layer 2 are ARP, the Address Resolution Protocol, and Spanning Tree Protocol, or STP. Again, remember these little three-letter acronyms and what they stand for. You will see those on an exam. The questions are going to be worded, and they're going to ask, where does the LLC live? What layer is ARP at? What layer is STP at? Those are types of questions you're going to get. They're not going to ask where Spanning Tree Protocol is. They're going to ask where, what layer does STP live at or operate. So we're moving up the stack to layer 3, or the network layer. The network layer uses logical addressing. Remember this, layer 2 had the physical addresses, now we're into logical addresses. The layer 3 addresses are designed to be routed to other networks or subnets and on the internet. Layer 3 networks operate independently of the MAC address. And layer 3 relies on a network protocol to route packets. Here and now we're talking packets. Remember in layer 2 we had frames. And these packets are used to route across networks. So the data units here at layer 3 are packets. So layer 2 we had frames, layer 3 we have packets. In layer 3 we use an IP address or a logical address for our devices. The IP address is 32 bits long and divided into 4 8-bit sections called octets and separated by a period or a dot. Each 8-bit section is a number from 0 to 255. A sample IP address is 192.168.100.27. We'll discuss IP addressing in more length in a later video. And on our inner network, no two systems can share the same IP address. In the original design, no two systems on the internet were to share the same IP address. Devices that operate at layer 3 are called routers. The protocols at layer 3 are the Internet Protocol, the Internet Control Message Protocol, or ICMP. When you use the command ping, that's one part of the ICMP protocol. Internet Protocol Security, or IPsec, and we have our routing protocols such as the Routing Information Protocol, or RIP, Open Shortest Path First, OSPF, and Enhanced Interior Gateway Routing Protocol, or EIGRP, among others. Routers have two primary functions. One, they connect multiple layer 2 networks to allow communication from one layer 2 network to another layer 2. So remember, we have broadcasts within layer 2. Routers don't propagate broadcasts. Routers actually stop broadcasts. And routers can also connect to different topologies. Again, we'll talk about topologies a little bit later. In a TCP/IP network, each device will have two addresses. It's going to have its MAC address and a TCP/IP address. They have no relationship to each other. Layer 3 packets are encapsulated in a layer 2 frame. So how does that look? Just like this. So layer 3 packets are encapsulated in a layer 2 frame. What did that mean? So remember, here's our frame. Our destination MAC, source MAC, ether type or type, our data, and our frame check sequence. The layer 3 packet goes within that data piece. How do we know what's in that layer 3 packet? The type will have a number in there, will tell us what that layer 3 packet contains. So we'll discuss how this data flows in a network in a later chapter, but remember, for this chapter, the IP packet's encapsulated in the Ethernet frame. So remember that, so we're working our way up the protocol stack to layer 4. Remember, our Ethernet frame is 1,518 bytes long. So what happens if you have data that's larger than 518 bytes long? How do you transmit across that network? Layer 4 makes this possible. Layer 4 allows us to break these packets down into smaller chunks of data called segments. So remember, at layer 2 we had frames, layer 3 is packets, layer 4 and above are all called segments. So what happens at layer 4, data is broken down. When it breaks down, it's called segmentation. Each of those smaller segments are transmitted across the network. When the receiving device gets at these segments, they place them back together in the correct order, and it's called reassembly. Two terms and protocols at layer 4. Term 1 is a connection-oriented protocol. And our connection-oriented protocol is called the Transmission Control Protocol, or TCP. TCP is described as a reliable protocol. The second term we have is connectionless protocol. And the second protocol we have is our connectionless protocol, which is the User Datagram Protocol, or UDP. This is also called an unreliable protocol. We'll discuss more about these in later chapters. The session layer is layer 5. The session layer is responsible for managing flow in a network. There are 3 things you have to remember about this: session open, data transfer, and session clones. So, computer A wants to talk to computer B. Computer A sends a message over to computer B saying, "Hey, I need to have some data to transfer." So computer B says, "Yes, awesome, I'm ready, send it over." Data is transferred. When it's finished, first computer goes, "Hey, we're finished transferring data, I'm ready to close the session." "Awesome, that's great, close it off." That process all occurs at the session layer, or layer 5. Layer 5, because of that managing data flow, has 3 terms that we also have at the here. One is called simplex. This is one-way communication. One-way communication, think of a broadcast. Someone just sends data and they expect the other device just to receive the data. Half duplex, this is where both devices talk, but only one device can communicate at a time. And full duplex, 2 devices can transmit and receive data at the same time. Layer 5 protocols are SMB, or Server Message Block, Password Authentication Protocol, or PAP, and Remote Procedure Call, or RPC. At layer 6 we have the presentation layer. Presentation layer is a translation layer. It translates data from English, if you will, the application layer, into something machines can understand. So it actually formats data. Along with formatting, we provide encryption and decryption at layer 6. And structures that we use, there's no specific protocols we'll talk about, but one is XML. Other terms you'll hear at the layer 6 are ASCII, ASCII, and EBCDIC. Layer 7 is our application layer. Application layer enables clients such as email, clients, web browsers, and other programs to access the network. It does this using an application program interface or an API. Protocols at layer 7 are Hypertext Transfer Protocol, HTTP, Simple Mail Transfer Protocol, SMTP, or the File Transfer Protocol, FTP. There are a lot more, and we will discuss a lot of these in later chapters. The second networking model we have to be aware of for the Network Plus test is the TCP/IP model, sometimes referred to as the DoD model. The TCP/IP model is very, very similar to the OSI model. The TCP model was developed a lot earlier than the OSI model, and the TCP model only has 4 layers versus the OSI model's 7-layer model. So since we've discussed the 7-layer model first, that's on the left. So we have the physical, data link, network, transport, session, presentation, and application. In the TCP/IP model, we have the link, internet, transport, and application. So the link layer corresponds to a combination of both the data link and the physical layer. The internet layer on the TCP model corresponds to the network layer of the OSI model. The transport layers are both the same. And the application layer combines the session, presentation, and application layers. That's it for Chapter 1. We'll get into Chapter 2 and more, Chapter 2 and 3, later in the week.